Chapter 4, Services, Article 230 in the NEC.
The term service is the electrical supply in the form of conductors and equipment that provides electrical power to the building or structure. Note that the source of the supply for a service must be from the utility. Service is the root word for 8 other terms that are defined in Article 100. It is a general term and usually includes the underground service or overhead service conductors, service equipment, and any associated metering equipment. A service conductor, overhead, is a conductor that connects the service equipment for the building or structure with the electrical utility supply conductors at the service point. This connection usually occurs outside of the building or structure. A service entrance conductor, underground system, is a conductor that connects the service equipment with the service lateral. The informational note following the definition of underground service entrance conductors in Article 100 points out that in some electrical service installations there may not be any service entrance conductors. In other installations, the service entrance conductors may not even enter the building. This depends on the configuration of the service and the location of the service disconnecting means. The service drop is the overhead conductors between the service point and the utility electrical supply system. Usually, the service drop conductors originate at the last utility pole or aerial support and continue to their point of attachment on the building or structure. Utility companies frequently use triplex or messenger cable assemblies as the service drop conductors to the building. In many of these systems, the steel messenger cable is used as the grounded or neutral conductor for the premises wiring system. The service lateral is the underground service conductors that connect the utility's electrical distribution system and the service point. The utility's supply system can originate from a pad-mounted transformer or an overhead supply system with the conductors emerging from the ground and continuing up the pole. The service point is the point of connection between the local electrical utility company and the premises wiring of the building or structure. An important design consideration in the electrical distribution system is the point at which the utility supply ends and the customer-owned or premises wiring begins. The NEC typically is only applied to the premises wiring. Service equipment is all of the equipment necessary to control the supply of electrical power to the building or a structure. It includes circuit breakers, fuses, disconnecting means, panel boards, etc. All equipment used as service equipment shall be identified as being suitable for use as service equipment and shall be listed per Article 230.66. Listing and labeling equipment as suitable for use as service equipment is one method to determine that the equipment is identified. Individual meter socket enclosures are not considered service equipment and need not be identified. Subsection 230.2a, b, c, and d are intended to provide some latitude for the designer and installer for a particular type of occupancy or a particular type of system. Subsection E contains important marking and identification requirements at the service disconnecting means where a building or structure is supplied by one or more services. Although service conductors are not provided with overload or short circuit protection, there may be installations in which there is a need to have the service conductors enter the building. Many high-rise distribution systems with large power needs utilize Article 230.2c to bring the second service into a building. Often, the second service is run to an upper floor electrical room for distribution to the upper levels of the building. In these types of installations, the service conductors enter the building without overcurrent protection. This is accomplished by meeting one of the 5 provisions of Article 230.6. Only service conductors shall be installed in service raceways or service cables. Service raceway is not defined in Article 100, but is considered to be any raceway that contains service conductors. Allowing only service conductors to be installed in a service raceway ensures that the fault of any type of service raceway will not affect the conductors. Per Article 230.7 Exception 1, this does not apply to grounding or bonding conductors which are permitted within the service raceway. Per Article 230.7 Exception 2, load management control conductors are also exempt from the general rule. These control conductors are permitted within the service raceway if they are provided with overcurrent protection. Because service conductors are not protected by overcurrent protective devices, additional care is taken to ensure that the conductors are not accessible to the general public. Per Article 230.9a, whenever service conductors are installed as open conductors or as multi-conductor cable without an overall outer jacket, a clearance of 3 feet shall be provided from windows that can be opened, doors, porches, balconies, ladders, stairs, fire escapes, or similar locations. The intent of this is to protect people from possible contact with these conductors by maintaining a 3-foot zone around the conductors. Vertical clearance from overhead span above or within 3 feet measured horizontally from platforms or other surfaces from which the conductors could be reached shall meet the requirements of Article 230.24b. The overhead service conductors are the overhead service conductors from the utility system to a building, structure, or service point. An example of the structure that could be supplied by an overhead system is a pole. In this case, the overhead service conductors terminate at a meter enclosure or disconnecting means which is mounted on the pole. Overhead service conductors shall have an ampacity that is adequate for the intended load. The load is determined based on the calculations required by Article 220. Other general considerations for the overhead service conductors is that they have adequate mechanical strength. Overhead service conductors are often subject to severe weather conditions which can put a great strain on the conductor due to the additional weight. Likewise, overhead service conductors are sometimes subject to long spans, which can also increase the stress on the conductors. For this reason, Article 230.23b sets a minimum size of number 8 copper or number 6 aluminum or copper-clad aluminum for most overhead service conductors. While some installations for limited loads of a single branch circuit allow the size of the overhead service conductors to be reduced, they are not permitted to be smaller than number 12 hard-drawn copper or equivalent per Article 230.23b, the exception. The general rule for overhead service conductors requires that they be installed so that they are not readily accessible. Overhead service conductors shall not be easily reached. They shall not be installed so that they can be reached without the use of ladders or other portable means. These requirements do not pose a problem for most installations. One area of concern, however, is when the overhead service conductors pass over roofs. Per Article 230.24a, overhead service conductors shall have a minimum vertical clearance of not less than 8 feet above the rooftops. If a roof is subject to pedestrian or vehicular traffic, such as in the case of rooftop parking garages, Article 230.24a, Exception 1, requires that the minimum clearance from the roof surface conform to the requirements of Article 230.24b4. Therefore, in this installation, the minimum clearance above the roof is 8 feet. For services of less than 300 volts between conductors, the required clearance is permitted to be reduced to 3 feet per Article 230.24a, Exception 2. Provided the slope of the roof is not less than a 412 pitch. Per Article 230.24a, Exception 3, a further clearance reduction is permitted for services not exceeding 300 volts between conductors when not more than 6 feet of overhead service conductor passes 4 feet or less horizontally above a roof overhang and the conductors are terminated in a through-the-roof raceway or approved support. If both of these conditions are met, the minimum clearance can be reduced to 18 inches above the overhang portion of the roof only. Per Article 230.24a, Exception 4, the 3-foot vertical clearance from the edge of the roof does not apply to the final span of the overhead service conductors when the conductors are attached to the side of the building. This exception is necessary for installations in which the overhead service conductors attach to the side of the building at an angle which does not permit the 3-foot clearance in all directions to be maintained. The second type of clearance that shall be maintained for overhead service conductors is vertical clearance from ground. The requirements of Article 230.24b establish 4 different clearances based on the voltage of the overhead service conductors and the type of traffic area over which the conductors are installed. A service mast is an assembly consisting of a service raceway, guy wires or braces, service head, and any fittings necessary for the support of the overhead service conductors. Service masts must be designed to support the weight of the overhead service conductors under varying conditions, including those when snow and ice may add additional weight to the conductor span. Underground service conductors shall be sized to handle the calculated load per Article 230.31a. The load shall be computed per Article 220. In addition to the underground service conductors shall have adequate mechanical strength for the application. To ensure that the conductors have adequate mechanical strength, Article 230.31b requires that the minimum size for underground service conductors be a number 8 copper or 6 aluminum or copper clad aluminum. Per Article 230.31b, the exception, the minimum size conductor is permitted to be reduced to a number 12 copper or a 10 aluminum or copper clad aluminum when the load served consists of a single branch circuit only. The general rule for sizing service entrance conductors is that the conductor shall have an ampacity per Article 210.15 that is suitable for the computed load. The load for the service entrance conductors shall be calculated per Article 220. Just as Article 230.2 limits the maximum number of services for a building or structure to 1, the general rule for 230.40 limits the maximum number of sets of service entrance conductors that can be connected to a single service drop, a set of overhead service conductors, a set of underground service conductors, or a service lateral to 1. There may be, however, installations where it is desirable to supply additional sets of service entrance conductors from a single set of service conductors. Section 230.41 contains specific requirements for the installation of service entrance conductors. Per Section 230.41, all ungrounded conductors that are used as service entrance conductors shall be insulated. The service entrance conductors shall be suitable for the atmosphere in which they are installed. Service entrance conductors are not permitted to be covered conductors. 19 listed wiring methods are permitted for installations of service entrance conductors in Article 230.43. Wiring methods that do not appear in Article 230.43, such as type NM cable, are not permitted to be used for service entrance conductors. These 19 wiring methods consist of various types of raceways, cable assemblies, open wiring, and auxiliary gutters. No matter what wiring method is selected, the service entrance conductors shall be installed per the specific NEC requirements for that particular wiring method. For example, if type MC cable is selected as the wiring method, the service entrance conductors shall be installed according to all the provisions of Article 330 metal clad cable. Type SE cable is constructed with a flame retardant and moisture resistant covering to protect the conductors within the cable assembly. This covering, however, does not provide a great deal of protection against physical damage. All service entrance conductors are required to be protected against physical damage per Article 230.50. Specific protection is provided by RMC, IMC, RNC, or equivalent. Specific support requirements shall be followed when cable assemblies or open wiring are used for service entrance conductors. Often these wiring methods are subject to severe weather conditions which may cause damage to the electrical components and the threat of a power outage if the system is not securely fastened to and supported by the building or structure in which it is mounted. Article 230.51a, service entrance cables, shall be supported at intervals not exceeding 30 inches. Check with the AHJ for specific interval requirements. In addition, the cable shall be supported within 12 inches of every service head, gooseneck, or point of connection to a raceway or enclosure. The means of support shall be by a cable strap or other approved means. The overhead service location shall be selected to minimize the possibility of water entering the service raceway. To avoid the entrance of water and moisture, service raceways are required by Article 230.54a to be provided with a rain-tight service head. The rain-tight service head shall be installed at the point of connection to the overhead service conductors and shall be listed for use in wet locations. The service head or gooseneck shall be installed at a point that is above the point of attachment for the overhead service conductors. This ensures that the water does not enter the service raceway or service cable. However, there may be installations where it is impracticable to locate the service head or gooseneck above the point of attachment. In these cases, Article 230.54c exception permits the point of attachment to be located above the service head or gooseneck. In no case, however, is the service head or gooseneck permitted to be located more than 24 inches from the point of attachment. The purpose of limiting the maximum number of service disconnects and requiring that they be grouped together is to ensure that the entire service or services, as permitted by Article 230.2, can be shut down at a single location with no more than 6 operations of the hand. Permission to install the 2 to 6 service disconnects gives latitude to the electrical designer, yet provides for a quick interruption of power in the event of an emergency. There are particular installations where application of this rule can be difficult. Motor starting current, for example, can increase up to 6 times the full load running current. In these cases, the overcurrent protective device shall be sized to permit the motor to start. A rating higher than the allowable ampacity is permitted by Article 230.90a, Exception 1, when necessary to handle motor starting currents.